Good morning, students. This is Dr. GVR Seshagiri Rao, Associate Professor in the Department of Mechanical Engineering, Institute of Aeronautical Engineering, Hyderabad. So, in this session, we will see when the shafts are subjected to fluctuating loads, how to design a shaft. So, actually, in previous sessions, we have studied. So, when the shaft is subjected to the combined bending and torsion movement, but additionally, sometimes the shafts are subjected to axial loads, and at the same times, and when the shafts are subjected to shock loads or cyclic loads. So it means when the shafts are subject to fluctuating loads, so how to calculate the diameter of the shaft. So here, so in this, actually when the shaft is subjected to twisting moment, so we will use equivalent twisting moment equation. So already you know, so that is TE is equal to m square plus t square. So m is here bending moment and t is the torsional moment, twisting moment or torsional moment. So and when the shaft is subjected to bending moment, so m is equal to half into m plus square root of m square plus t square. So already we have learned, and also we did some problems on this. So now in this session, so the shaft subjected to fluctuating loads means whenever the shaft is subject to cyclic loads. So in cyclic loads, so what will happen after some cycles, the component will fail. So your component means shaft will fail due to the fatigue property. So to avoid this failure, need to use some factors. So that is fatigue factors. So here bending moment of fatigue factor and torsional moment of fatigue factors are there. So in this first one, when calculating equivalent twisting moment, so need to multiply Km and Kt. What is Km and what is Kt? Km is the combined shock and fatigue factor for bending load. Kt is the combined shock and fatigue factor for torsion. So that is depends upon the type of load. These values we have to take. So here, after taking these two values, you should multiply these factors with the bending moment and torsion. You will get equivalent twisting moment. Similarly, the bending moment also. Half multiply with half inside bracket, Km multiply with m plus square root of Km into m whole square plus Kt into t wholes. So this is equivalent twisting moment and equivalent bending moment. So now, so recommended values, we will see the recommended values for Km and Kt. The bending moment fatigue factor and twisting moment fatigue factor. So the nature of the load, the type of load is, suppose in the case of a stationary shaft, the Km value and Kt value listed like this. So first case, gradually applied load. Second case, suddenly applied load. So gradually applied load is Km is 1 and torsional twisting moment is 1. In the case of suddenly applied load, so nothing but impact loads. So the Km value you should take 1.52 2 and Kt is 1.52 2, same value. So second case is rotating shafts. The gradually applied load or steady load 1.5 and Kt is 1 and suddenly applied load with minor shocks. So minor shock loads, so 1.5 to 2 and 1.5 to 2 Km and Kt. Similarly, third one is in rotating shaft, suddenly applied load with heavy shocks. So here, see, one is minor and another one is heavy. Heavy shocks, you should take the Km value. So when compared to the other values, very high, 2 to 3. You can take 2, 2.5 and 2.8 or 3. The KT also 1.5 to 3, up to 3 value to take. So these are the recommended values for Km and KT. These values only you should consider for calculating when the shaft is subject to fluctuating loads. It may be twisting moment, equivalent twisting moment, or the bending moment. So these factors are very, very important. So next one, we'll see one problem. A shaft made of mild steel is required to transmit 100 kilowatts at 300 rpm. The supported length of the shaft is 3 meters and it carries two pulleys, each weighing 1500 Newton, supported at a distance of 1 meter from the ends respectively, assuming the safe value of stress and determine the diameter of the shaft. So in this, so first given data write down. So the given data is 100 kilowatts and N is 300 rpm and L is 3 meters and W is 1500 Newton. We know that the torque transmitted by the shaft T is equal to 60P by 2 pi N. So that is P is equal to 2 pi Nt by 60. So from this equation, so you can calculate the torque. So after that, we will find the diameter of the shaft by using equivalent twisting moment and equivalent bending moment. So first of all, so draw the diagram and then find the RA and the RB values. So already this problem we have discussed in the previous session. So this is the normal problem without any fluctuating loads and shock loads. Clear? So diagram I will draw. So A and B, and here each weighing 1500 newtons pulleys supported at a distance of 1 meter from ends, from this end 1 meter and from this end 1 meter. So assuming the same value of the stress and total is 3 meters. Total 3 meter. Clear? So here reaction forces RA and here RB will act. So how to calculate reaction forces and how to calculate bending moments we have discussed in the previous session. Now we will see when the shafts are subjected to fluctuating loads, we will see one problem on the fluctuating loads. See, a mild steel shaft transmits 20 kilowatts at 200 rpm. It carries a center load of 900 newtons. It is simply supported between the bearings 2.5 meters apart. Determine the size of the shaft. If the allowable shear stress is 42 megapascal and the maximum tensile or compressive stress is not to exceed 56 megapascal. So what size of the shaft will be required if it is subjected to gradually applied loads? So here the given data, P is equal to 20 kilowatts and N is 200 rpm and central load is W is 900 newtons and the distance L is 2.5 meters. Determine the size of the shaft. The allowable shear stress is 42 megapascal and compressive or tensile stress not to exceed 56 megapascal. So your condition is gradually applied load given. So what size of the shaft will be required? So in this, the given data already written, draw the diagram A and B, reactions forces there, and here center load 900 newtons. The shaft is mounted in between two bearings. What is the length? Length is 2.5 meters. Here, the size of the shaft, the D, diameter of the shaft in mm, and we know that the torque transmitted by the shaft is, we may calculate by using this equation. Substitute given values 20 kilowatts and and calculate the T. The maximum bending moment of a simply supported beam shaft carrying a center load. So it assumed as a simply supported beam. So the bending moment is equal to WL by 4. WL by 4. So clear. So W already you know, and then L value given and calculate bending moment. Clear. So after the torque also calculated, bending moment also calculated. So now that the equivalent twisting moment TE is equal to square root of m square plus t square. So how much here calculated, how much value got here? 1108 10 to the power of 3. So equivalent twisting moment, you already know, pi by 16 into shear stress into dq. So substitute here calculated values and find d value. So this is a normal procedure. Now, when it is subjected to gradually applied load, so how to calculate the size of the shaft? The equivalent bending moment, you know that already calculated by using twisting moment, and one more equation is there, that is equivalent bending moment, and apply calculate D. So here bending moment equation already you know, ME is equal to half m plus square root of m square plus t square. So here ME is equal to pi by 32 into dq to sigma b. So by using these two equations, you got two values D. So one is 53.4 and previous case 51.2. So take the larger value of the two calculated values. So here D is equal to, the larger value is 53.4. So you may assume, you can say 55. So already I told you in previous session, always you should take the standard values of shaft. So here 25 to 60 mm dia shaft in 5 mm steps. So similarly 60 to 100 in 10 mm steps. So now 25 to 60 to 25 first size, and 30 and 35, 40, 45, 50, 55 and 60. So here our value is in between these two, 50 to 55. So 53.4. So you can say 55 is our final diameter of the shaft. So now the second case is how to calculate the size of the shaft when the shaft is subjected to fluctuating loads. The type of nature of load is here given, gradually applied load. So to calculate, so already we have discussed, we have to use fatigue shock factors for bending and torsion. From table, for rotating shafts with gradually applied loads, the Km value and Kt value have taken 1.5 and 1 respectively. So again calculate equivalent twisting moment Te. Te is equal to square root of Km into m whole square plus Kt into T whole square. We know that equivalent twisting moment Te is equal to pi by 16 into tau into dq. So by using this equation, calculate diameter. So the calculated diameter is 53.6 mm. Similarly, calculate equivalent bending moment. So the bending moment equation is half into Km into m plus square root of Km into m whole square plus Kt into T whole square. So finally, you can write Km into m plus T. Now that equivalent bending moment Me is equal to pi by 32 d cube into sigma b. So use this equation and calculate the diameter of the shaft. So here also two values you got. One is 53.6, another one is 57.7. Take the larger value. So taking the larger value of the two values, we have used 57.7, you can say 60 mm as per standard diameters of the shaft. So like this, we have to find the size of the shaft when the shaft is subjected to gradually applied load or fluctuating loads. So one more problem we will see. Design a shaft to transmit power from an electric motor to lathe head stock through a pulley by means of a bell drive. Here a bell drive is there. So the pulley weighing 200 newtons is located at 300 mm from the center of the bearing. The diameter of the pulley is 200 mm and the maximum power transmitted is 1 kilowatt at 120 rpm. The angle of lap of the belt is 180 degrees. So that is theta. The coefficient of friction between the belt and the pulley surfaces is 0.3. This is mu. So here the pulley is mounted on a shaft. The shock and fatigue factors for bending and twisting are directly given. Km and Kt. Km is 1.5 and Kt is 2.0. The allowable shear stress shaft may be taken as 35 megapascal. So now, how to solve this problem we will discuss. First of all, given data, given W 200 newtons, L is 300 mm and diameter 200 mm and power 1 kilowatt and N is 120 rpm. So theta converted into radians. So mu, coefficient of friction, angle of contact 180 and Km and Kt, shear stress values. So torque transmitted by the shaft already you know T is equal to 60p by 2 pi n. So find out torque. So the given diagram, to draw the space diagram like this. So the belt, the shaft, this is a pulley and shaft bearing. So here belt pulley, their belt tensions are T1 and T2. So T1 is the tight set tension, T2 is the slack set tension. So the D is the diameter of the pulley. The small d is the diameter of the shaft. You need to find. So here self weight also will add. So T1 plus T2 plus W. So this way total weight, total load acting on this pulley is downwards. That is T1 plus T2 plus W. So here the side you draw like this. Now tensions ratio calculate by using belt tensions ratio T1 by T2 e to the power of mu theta. Apply this relation. So you may use this one also, taking anti-log, and then you will get T1 by T2 is equal to 2.57. Mu is the coefficient of friction, theta is the angle of contact. From these two equations, so you will get T1 and T2 values. The one T1 to 1303 and T2 is the 507. So one relation is T1 this one, and another one is P is equal to power transmitted T is equal to T1 minus T2 into R. Clear? So T1 minus T2 will get T1 minus T2 796 newtons and T1 by T2 is equal to 2.57. So solve these two equations, you will get T1 and T2 separately. After that, the total vertical load acting on the pulley. So much load acting on the pulley, WT, that is T1 plus T2 plus W. So you will get 2010 value. So similarly, calculate bending moment on the shaft, load multiply with the length. So that is bending moment multiply with load multiply with L, you will get bending moment. So the bending moment is, so you got 603 into 10 cube. So similarly, calculate equivalent twisting moment. The equivalent twisting moment when the shaft is subjected to fluctuating loads, km into m whole square plus kt into t whole square. So here substitute the above calculated values and bending load, fatigue shock factor and twisting moment shock factor. So for all the values of substitution, after substitute the all values, you will get the T equivalent twisting moment. So now this equivalent twisting moment equate to equation 5 by TE is equal to 5 by 16 into tau into dq. Clear? So it's shear stress value given and then D need to calculate it. So one is over. Next one is equivalent twisting moment equate and D is the final value 51.1. So you can say this standard value 55. So here bending moment calculated and the equivalent twisting moment. So similarly need to calculate equivalent bending moment. So two values you will get and then take the larger of the calculated values you can fix as a final diameter of the shaft. So like this we need to calculate the size of the shaft whenever the shafts are subjected to shock loads. The main thing, the important factors are bending load, fatigue factor and then twisting moment fatigue factor. So why? Because so the shafts are subjected to cyclic loads. So after some time, after number of cycles, the component will fail. The shaft or component will fail due to this fatigue loading. These cyclic loads. This phenomena is known as the fatigue load, fatigue phenomena or load type of load is here fatigue load. Normally, all automobile engine components or mechanical components are subjected to fluctuating loads only. So that we will always take the factors to avoid failure. So your final diameter obtained 55 mm. Thank you.
Like, share and subscribe. Hit the bell icon for more updates.